Hello guys, I'll try to show you today about uh, making the tractor lines, and with them I'll try to show you how to construct a circle from the radius of that circle, which could be a parametric one. So let's get started. First, what I would do is to have a domain, to construct a domain from 2 points. I have, for example, 15, and let's just make this one 45. Then this one and this one, I have this domain. Then the next one would be to construct the range. Then after defining this range, we have this range. Then using this range, what I would do is to have the x, y, and z coordinates for constructing a point. So I'll try to construct a point. Construct point here. So this is the x value, as you can see from here, and the y value. This value, as you can see from here. So this would be our domain here, and our range continues from that direction. So I don't need a z coordinate for now. I will use only this x and y coordinates. So what I would do is I will try to define a point from it. So these are my points, but the thing is, I don't need this line, but I need the whole lines, the whole line. So for example, what I mean by it is, for example, we have this rectangle. From this rectangle, it is showing me the pointers, which are like this, then, but I don't need these points. But what I would need is the whole list of pointers in here, like this, the whole line, because I need the whole points to construct a circle. So what I would do is just directly go here and try to either x or y, try to craft one of them. For example, let's craft the x. Let's craft it so that we have the whole values in here. So after having this, we can go here and flatten all my data from here to have my actual points. Then the next one would be to have the line which you want it to be as a tractor line. So what I would do is, for example, the line would go, for example, here, and it goes out here. So what I would do is go here, and I want to define this point, a curve. Then I'll right click on the curve and set one curve. So there is an enter. Then now we have these tractor lines. So technically what we will try to do is to take the points, these points on the line, the distance between these points to the line, and then to get the distance from this line, this point to this line, this point to this line, this point to every point to this line, so that will define the radius of our circles parametrically. So what I would do is I can just go to the curves and go to this analysis, and here we have the curve closest point. So I will use this curve closest point. So as you can see from here, this curve closest point takes two inputs. The one is the point, and the other is the curve. The curve is the one which we draw here, so we'll directly connect it here. And the point is this one. So it will directly take this point, as you can see from here. It will direct these points on the line, so we have these points. But first let me show you the difference. Let's take a circle here. So this circle will take also two inputs. The first one would be its plane, and the other one would be its radius. So if you take this plane, as you can see from here, it will construct these points based on one unit from each direction. Like the radius would be 1 unit to every of these points. But for example, let's make it 2 units, which means bigger circles, as you can see from here. But so let's make this real number so that we could easily change these values. But as you can see from here, the whole values which are used here have the same radius, but we don't need it for now, so I will delete it. So what I would do is using this distance which we have here. Here, if you didn't flatten it, let me show what will happen. You only have the coordinates, which is not the distance anymore, so it will not construct you what you need. So what I would do is go here and flatten my data, so that I have now these values which go from, for example, let's just take here the distances, which every point have the distance between the point itself to the line. So we have here 120 values here, 121 because it's used also 0. So the next thing what I would do is, if I just directly use this radius to here, it will be really messed. So what I would do, what I would rather do is I will try to make the bounds. So I have the remap. So now when I see this one from 0.07 to 13, so the next thing I need is to construct also domain. Construct a domain from 2 points. Domain from 2 points. So you have now 2 points, two numbers. From these 2 numbers, you can construct your domain. So that you can easily manage your the data entry. So that let's just take from 2, or from 2, yeah, let's just take 2 for example. Then let's make this also real number. Then another one, which is, for example, let's just try to define them in, for example, 5. So from 2 to 5, so this one would be our domain here, and we have the bounds here. So what I would do is I'll try to remap these numbers. So there are 2 things. The first one is to download this remap plus from Rhino, Football Rhino. Then you can easily, you don't need to go through all the steps that we are doing. For example, here you don't need to construct this one, these things. You don't need them. You can just directly insert your data, and you can insert minimum and maximum. Then you have all your values. You can download this from Rhino, Football Rhino. And the other one is just the regular way, which is the remap numbers. So now we have these values which are taken from here. Then we have this the source domain, which is this our bounds from here, and the target here. So now we have whole our remapped radius numbers. So I can just directly inserted here. As you can see now, it's also a bit complex here because the values here are much bigger, so I'll try to manage them between, and then from 0.5 to here. So as you can see from here, the radius of these circles are already defined here based on their distance from this curve. So this is what you will do to have these parametric distances. So you can also change between the values, which is to make these circles bigger while they are going through this line, which are bigger, and otherwise if they are far, we can make them smaller, which is, we can do it here. That's why I make it in groups here. So you can take this one and this one here. So the ones which are near to this line are bigger radiuses, and the other ones will be smaller. So I don't need this one for now. I have this one. So now you have these surface already. So you can have the surface from out of them. I can make a surface from here. As you can see from here, I have these surfaces. Then based on this, also you can also make the extrude options if you want to also extrude. So these are our bases, and also our for our this is our direction, which is z. Let's make it z, unit z direction. So from this, let's just see it on our, as you can see from here, they have also the same kind of height, but we don't need them to be the same. So what we'll do is, for the factor, I'll take also the numbers which you get from here. So as you can see from here, it changes. The ones which are here are smaller, the ones which are here are becoming bigger. But let's make the other remap because the heads are much more bigger, plus here. So let's make from, for example, 3 to 10, 9 or 10. So this is our minimum and our maximum, the data which we get from here. Then I will use this data to here. As you can see from here, now we have parametric circles at the same time, also in the height also. So in this video I have tried to show you these parametric tractor lines. Also, if you have any question, you can type it and I'll try to answer it. So after this extrusion, I can make from this extrusion, these are all closed periods, so I don't need to close them, they are already closed. So what I would do is go here and bake it, for example in layer 2 here, group if you need group, yes, if you not, you don't need to group them, but let me make them in groups. I'll try to make these ones invisible. As you can see from here, now we have this let's just see them as rendered. So here, based on the lines, we have tried to create this parametric surface at the same time in terms of extrusion, and also in terms of the planar distances. So this is the whole thing that you need to do. I hope you enjoyed the video, and thanks for watching, and don't forget to subscribe so you can see more updates on the videos. So thank you.